Hey guys, welcome back to the second part of the content for P6, rational expressions. Remember, rational is just a fancy word for fractions. And so in the first video, we covered simplifying, finding the domain, multiplying and dividing. And so in this video, we're going to do the last two things. We're going to talk about adding and subtracting rational expressions, as well as simplifying complex rational expressions, which just is like fractions inside of fractions. How do we handle that? And there's a couple of different ways we can do that. So when we're adding and subtracting, what you need to remember is what the rules are for regular fractions, right? So if you have 2 over 7 plus 3 over 7, how does that work? What does that mean? Well, that means the numerator means how many you have, and the denominator means the kind that you have. So just like terms, if you have 2x plus 3x, you can do 5x. But if you have 2x plus 3y, that doesn't add together, right? Well, if you have 2 sevenths plus 3 sevenths, then you have 5 sevenths because the top tells you how many you have. But if you have, 2 sevenths plus 3 fifths, we can't add those because these are not the same. These are not the same kind of thing. They're not like terms. And with x's and y's, there's nothing you can do. But here, there is something you can do because we have the opportunity to create what's known as a common denominator. All right. So just a reminder again. If you already have the same denominator, here we have x plus 1 the whole time. We have x plus 1. And so this means that the x plus 1 represents the kind of thing you have. Obviously, x is not allowed to be 1 here, negative 1, excuse me, because that'd make the denominator 0. So we note that. But then we have x minus this group. Remember, there's an implied parentheses here that you won't see in your expressions typically, but I will try to put them in there because you don't want to forget. You don't want to go quote unquote canceling stuff. You can't divide these x's away because they're not the same factor, stuff like that. And so what happens here is we just combine the numerators. Okay, so the numerator becomes x minus the group 3x plus 2, right? And then what happens? We take this negative sign and we distribute it through. Okay, it's like a negative 1, so we distribute it through. And that gives us 3x minus 2, and then we can simplify the numerator, all right? There's no reason to factor here. You're welcome to factor if you want to, but there's no need to. This answer is fully acceptable. Now, the reason to factor would be if indeed so you combine the x and the minus 3x, you get negative 2x minus 2. And then in this case, this doesn't always happen. In fact, it doesn't happen very often at all. You factor out the negative 2, and then there's an x plus 1 here and an x plus 1 here. And what happens, remember, from last time, we divide those away and get a 1. So you get negative 2 times 1 divided by 1, which is negative 2. But then you do need to bring this down and remind us that x is not allowed to be negative 1. Okay? So that's how you handle it if the denominator is the same. It's pretty simple. If the denominator is not the same, however, we need to find what's known as the least common denominator. And the least common denominator is the same as the least common multiple you used to find back in basic algebra class, which is a product of all of the denominators. And you take the highest power of each factor. So it's a product of every factor of the denominator. So what that means is the first step is you have to factor each denominator, right? So once again, factoring is coming into play big time here. And so then once you find the LCD, you have some more steps to do. So let's talk about the lowest common denominator first, and we'll come back and look at these steps, okay? Finding the lowest common denominator. The first thing you need to do to find the lowest common denominator is factor. So x squared minus 10x plus 25, that factors into x minus 5x minus 5, right? 2x minus 10 factors into 2x minus 5. So what are the factors of your denominators? The factors of your denominators are 2 and x minus 5. Those are the only two factors you've got. So you need to bring a 2 over, okay? And then you need x minus 5, but you need the highest power of x minus 5 because these two x minus 5s here include one x minus 5, right? You don't want three x minus 5s. That's not a lowest common denominator, a least common denominator. That's not least because this x minus 5 here, this group of x minus 5s, includes one x minus 5. So you only need two of them, okay? So the least common denominator is 2 times x minus 5 times x minus 5. That's the least common denominator, okay? Now, go back to the steps. Once you find the LCD, what do? You rewrite each expression with the common denominator, okay? Well, how do you do that? You can't just multiply stuff. You can't just change the denominator. That doesn't work, right? So what do you have to do? You have to multiply the top by the same thing that you do to the bottom, okay? So let's go back. Our lowest common denominator is 2x minus 5 times x minus 5, okay? So if we look at this problem, right, we wanted to subtract these two guys from each other. So the first term is x times x squared, or x over x squared minus 10x plus 25. This had x minus 5 as its factors. This guy had 2 times x minus 5s. So for the lowest common denominator, what's missing from this denominator? What's missing is just the 2. And from this denominator, what's missing? The x minus 5, a second x minus 5 is missing, okay? So here, what happens is the x minus 5s, you get a 2, right? You need a 2 in here, but if you multiply the bottom by 2, you got to multiply the top by 2. It's that simple, all right? What happens in the second one? All right, you needed a second x minus 5. And so if you multiply the bottom by x minus 5, you got to multiply the top by x minus 5. Okay? And so do not FOIL out the bottom. Do not FOIL out the denominator. And the reason that I'm telling you that is because if you FOIL out the denominator, what happens is you lose the chance of possibly reducing later. Because remember, the only way you can simplify fractions is if you have common factors in the top and the bottom multiplied together, then you divide them away, right? And don't divide them away now. You want these these are more complex than they were before. They have common factors you could cancel, but you don't want to cancel them. The whole point is you need a common denominator. So now we have one, all right? So we take this 2x over 2 times that stuff and this x minus 4 times x minus 5 over that stuff, and we just subtract, right? Now we have the same denominator in both cases. So the denominators are the same. You subtract the numerators, okay? And there's no canceling can happen here because this whole group here on the top, right? This is one big, huge group now that we've put them together. There's no breaking that group up. But what you can do is you can FOIL this out, okay? So, what happens? All right, we FOIL this out. We get x squared minus 9x plus 20. We distribute the negative sign. We get negative x squared plus 9x minus 20. We got a 2x in there. Notice we haven't FOILed out the bottom at all. All right, and then what happens? You combine the x's, you put the x squared out front, and you get negative x squared plus 11x minus 20. This does not factor at all, and so there's no reason to factor it out. If it did factor, then you would want to try to simplify if possible. And that's the final answer. All right, so it's perfectly good, perfectly legit to leave it like this. The bottom factored, the top not factored. That's totally fine. This is the final answer and works great, okay? So you're going to want to go through and do a lot of practice with these. This is a relatively complex problem. You'll have some examples and some practice that's simpler than this one, and then you'll have some that are this complicated. But you need to go through and do a lot of practice on this because this is where a lot of students struggle, okay? All right, So that's the final answer. No simplification needed. Complex fractions, again, have numerators and denominators that have one or more rational expression. And so your textbook gives you a method for simplifying rational expressions, complex expressions, and I'll let you see those at the end. But I'm going to show you my preferred method. This is a method that's not in the book, and the reason that I prefer it is because it's more step-by-step. Okay, so here's an example, and notice that this is a complex fraction, but here's your numerator that has 2 fractions in it. Here's your denominator, just has 7. No big deal, all right? And so these are the steps that I suggest that you do. Now, if you're real solid with fractions and factoring and reducing, then you can probably take it and be fine and use their method. But this is a method that this is a much more step-by-step. It's a little slower. It doesn't get you to the answer as quickly, but it does get you to the answer methodically. And for those students that make silly mistakes, I guess, if you will, this is a better method for you probably, okay? So we treat the top and the bottom completely separately. And in this time, there's no bottom to simplify. It's just a 7, right? But even if you had a really complex fraction, if you had a bunch of fractions in the bottom too, you add the top just like we just did. You do the bottom just like we just did. And then you keep, change, flip. I'll show you what I mean by that, okay? So the first thing we do is we do the top, right? So what do we have to do to add or subtract the top here? What do we need? We need a lowest common denominator. So what's the lowest common denominator? Well, it's just a product of the factors of the denominators, and since x and x plus 7 are different denominators, then they are just the product, all right? So we take 1 over x plus 7 minus 1 over x. We want to get a lowest common denominator, so what do we need? New. The new stuff we need, for this one we need an x. Well, if you're going to multiply the bottom by x, you need to multiply the top by x. This one needs an x plus 7, and if you're going to multiply the bottom by x plus 7, you better multiply the top by x plus 7. Okay? So this is our process we just talked about. And then from there, what do? We combine the numerators. We get x minus x plus 7. Remember, don't forget your parentheses. This is x times x plus 7. You can't simplify that because this numerator, again, this numerator is a whole big fat numerator now, so you can't break it apart. But I can distribute the negative sign. All right, so you distribute through. This makes it x minus 7. Don't forget that negative to there. All right, and then x minus x is 0. And so you get negative 7 over x times x plus 7. All right? But that's only the first part, right? That's only the first part. What needs to happen is that's the numerator. And so now what we do is we bring this down and we do our keep, change, flip thing. And so this is negative 7 over x times x plus 7 all over 7 over 1. We think of this as 7. We think of it as over 1, right? That makes it a fraction. And now we keep the numerator the way that it is. We change this to a times, and then we flip this to a 1 over 7. All right? And then, of course, 7 divides 7 and leaves a 1. Don't forget that negative sign. And so you end up with negative 1 on top and x times x plus 7 on the bottom. And then, of course, x is not allowed to be 0 because of this x, and it's not allowed to be negative 7 because of that plus 7. Okay? So you got to denote your domain every time. All right, so that's my method. That's the way that I suggest that you do it, to be honest with you, because the other method is a shortcut, and shortcuts are great if you really know where you're going, but it's easier to get lost when you're taking a shortcut. And so if you're struggling with this at all, stick with my method. It takes longer. Bear with it. And I'd much rather you go slow and get, or slower and get to the end properly than to make silly mistakes to just get done faster, okay? But for those of you that want to see it, I am going to walk you through the books method real quickly, all right? So in the books method, what they do is they look at the lowest common denominator for all fractions involved. So the top fractions, and if there were any here, and they're not, right? If there were any here other than just over 1, they would include the bottom fractions too. So if this was 7 over x squared, we'd have to include that as part of the common denominator, okay? And then what you do is you multiply the numerator and the denominator at the same time by the lowest common denominator of x times x plus 7. Remember, if you do the top and the bottom at the same time, that's legal, right? But then what happens is you have to distribute this x times x plus 7. All right, you have to distribute that. And this is where students make silly mistakes. And so what you have to do is, as long as you can do this, I'm fine with it. All right, but you have to think of this as like over 1, and this is over 1, right? And so this x plus 7 divides that x plus 7 and leaves a 1. This x divides that x and leaves a 1, right, in both spots. But that means the denominators are all gone now, except for 1's, and that was the whole point. And so now I have the numerator is just x minus x plus 7, right? The denominator is the same. And then as we go beyond that, okay, then the next step is to distribute that negative sign. Okay, distribute that negative sign, and then you can subtract the x's, right? And then one last step, of course, for them is they had to divide these 7's away, right? Divide the 7's away, and you're left with a 1, negative 1 on top, and an x times x plus 7 on the bottom. Okay, so you're welcome to use that method. That's great. The method's fine. But again, if you find yourself making silly mistakes, don't use that method. All right, go back and use my 4-step method. It will take a little longer, but it'll be worth it. Okay, hope that helps. See you later.